Good morning students. Today we are going to see about the classification of plants. Before going into the classification of plants, let me see what is the need for classification. Before saying the need for classification, let me tell you one situation. You just imagine. Imagine if you are going to the library and if you want to take the book which is called as Harry Potter's story book. As you walk into the library, some renovation work is going on there and all the books were scattered all around the library. So, what will you feel? You feel just irritated to see all the books spread over full of library, and you will be fed up in searching the book you want. It will be very hard for you to find the exact book you are looking for. It may take many hours to search that book. So, the next day when you come, you can see the library which the books were all arranged orderly. Now, it will be very easy for you to find out the Harry Potter book. You can go to the fantasy section directly and you can take the book which you want. It will take only less than 10 minutes to find you out. So, that is what the thing happens actually. The same thing is applicable to the plants also. So, imagine how many types of plants are there in this world. It is a vast assemblage of plants, millions and millions of plants are there around the world. It will be very difficult to study and analyze the characteristic feature of all the plants at a time. If all the plants were put together in one group, will it be comfortable for us to learn? No, definitely it will not. The classification of plants is very much essential because there is a vast diversity of organisms exist in the world. We have to sort out, and we have to unless we sort out, we cannot learn or analyze and compare anything between the plants. So, unless they are organized into a manageable category, it is very difficult for us to identify the plants. So, biological classifications are the inventions of biologists based upon the best evidence available. The scientists which are present in a particular period, he will be analyzing what are all the characteristic features he will be knowing. So, what are all the characteristic features he can analyze. Depending upon that, he will classify the plants into his own categories. The scientific basis for cataloging and retrieving information about the tremendous diversity of flora is known as classification. So, you will be having an idea now what is meant by classification. That is the scientific basis for cataloging, that means separating, classifying and retrieving information, that means bringing back the information about the tremendous diversity of flora, that means lots of differences existing among the plants. This is said to be tremendous diversity of flora. So, classification paves way for the arrangement of organisms into groups on the basis of the similarities, dissimilarities and relationships. So, classification only leads to the arrangement of organisms. How to arrange the organisms? Only on the basis of the similarities existing between them and the dissimilarities existing between them, and also the relationship between the organisms. Depending upon all these categories only, plants can be classified easily, so as to make the things easier. The purpose of classification is to provide a systematic arrangement expressing the relationship between the organisms. So, what is the purpose of classification? To provide a orderly arrangement. That means systematic arrangement means orderly arrangement which expresses the relationship between the organisms. Taxonomists have assigned a method of classifying organisms which are called as ranks. So, previously in the beginning of the lesson itself we studied there were many taxonomical hierarchies where the organisms were classified into different ranks. So, taxonomists, they have analyzed a method of classifying the organisms into categories called as ranks. These taxonomical ranks are hierarchical. That means they are classified according to the step by step manner categories. That is, of course, the scheme of classification has to be flexible, allowing newly discovered living organisms to be added where they fit best. That means this classification should be flexible, so that any other information also can be added to make the classification very effective. Now, just an information about the Botanical Survey of India, that means how the Botanical Survey of India has been evolved. That is on 13th February 1890. That is vast before independence, there was formerly one group was constituted and designated as Botanical Survey of India. Actually, it was a formality to form a group to survey the plants existing in the world, but it was not function that much effective. After independence, the need was felt for a more comprehensive documentation. That means after independence, there was a very need that elaborate documentation of the country's plant sources is needed to boost the economy of the country. Then for that group, Padma Shri Dr. E.K. Janaki Ammal was appointed as officer on special duty on 14th October 1952. Then after independence and also after republic, Dr. E.K. Janaki Ammal was appointed as officer on special duty on 14th October 1952 as a head of Botanical Survey of India. Then reorganization plan was finally approved by the Government of India on 29th March 1954 with the Calcutta as the headquarters of BSI. See, after that, after Dr. Janaki Ammal was appointed as the officer, a organization plan was approved by the Government of India on 29th March 1954 with the Calcutta as the headquarters of Botanical Survey of India. Jammu Tawi Botanical Garden has been named after Dr. E.K. Janaki Ammal. So, you can see the photograph of Dr. E.K. Janaki Ammal. So, we should be proud that even during that period, lady was appointed for such a post. Understanding the classification of organisms can give an insight into other fields. That means making our knowledge wider to see the characteristic feature of other fields also, not only the morphological characteristic features. That is, other fields like as cytology, physiology, biochemistry, molecular biology, palynology, likewise we studied, no. So, for everything we have to analyze and we have to classify the plants according to the similarities, and has a significant practical value. The knowledge we gain from other fields also has a significant practical value in analyzing and classifying the plants into different categories. And then classification helps us to know about different taxa, their phylogenetic relationship and the exact position. So, by classifying the plants alone, if we are not classifying now, we cannot know anything. Only after classification, we will be able to know about the different types of taxa existing among the plant groups. Their phylogenetic relationship, that means the relationship, that is evolutionary relationship, what is the relationship they have with the past plants. And also by analyzing all these things only, we can know the exact position of a plant. That is, exact position means the exact position in the whole plant kingdom. Then it helps to train the students of plant sciences with regard to the diversity of organisms and the relationship with other biological branches. So, and by knowing that classification only, the classification only will help the students to get trained with the knowledge of plant science. Plant science is nothing but botany. With regard to the diversity of organisms, unless we know the classification, we will not be able to find out the different varieties of plants are existing in the world, and the relationship with the other biological branches, how they are related with other biological branches also will be able to know only if we know the classification. Now, we will move on to types of classification. So, generally the taxonomic entities are classified into 3 ways, that is artificial classification, natural classification and phylogenetic classification. So, on what basis these are all classified like this, how they are given this name, we will study everything in detail. First we will study what is artificial classification. First, let me say something, an introduction about this artificial system of classification. He classified the whole plants into 24 classes in his book called as Species Plantarum. He was a great Swedish botanist and he is said to be father of taxonomy. I said he outlined the artificial system of classification in his famous book called as Species Plantarum in 1753, where he has described about 7,300 species and arranged all these plants in 24 classes. How he classified, on what basis he classified these plants means, he classified the plants only on the basis of stamens. Stamens is the male reproductive organ, that is androecium, the male sex organ. This system of classification was considered to be an important system of classification on the basis of the number, union. Union means addition and cohesion. Addition means how the stamens are all united with each other. When many number of stamens were present, how they were united together, that is called as addition. Cohesion means how this stamen is attached with other parts of the flower, like sepals, petals, gynoecium will be there, no. So, how it is attached with the other parts of the flower. So, depending upon the union, length and distribution, he classified only on the basis of the stamens, he classified the plants. And after that, the classes were further subdivided on the basis of the carpal characteristics into orders. What is meant by carpal? Nothing but gynoecium, the female sex organ. Hence, the system of classification is also known as sexual system of classification, since he considered only the characteristic feature of stamen and carpal, not the phylogenetic characters are considered here. The phylogenetic characters are not considered, only the morphological characters are considered. So, this system of classification is called as artificial system of classification. So, even after the death of Linnaeus, this system of classification was followed for more than 100 years because of its simplicity and easier way of understanding and identification of the plants. Totally unrelated plants were kept in a single group, whereas closely related plants were placed in widely separated groups. Since he analyzed only the characteristic feature of the stamens, he did not take into account of other characters. Totally unrelated plants were kept together in a single group and closely related plants were kept apart. We can see some examples for this. Example 1, Gingiberaceae of monocotyledons and Anacardiaceae of dicotyledons. See, now here itself they have said that Gingiberaceae belongs to monocots, Anacardiaceae belongs to dicots. So, entirely the characteristic features will differ from each other, but these two were placed in the same group called as Monandria, since both the families possess single stamen, but all the other characters will not coincide with each other, will not go together. Entirely both the characters will be different. And one more example we can say, Prunus. Prunus was classified along with the cactus because of the same number of stamens. So, Prunus is the category of plants which consist of many fleshy fruits such as strawberry, like that. So, many useful fruits are produced in that Prunus group, but cactus is a xerophytic plant. These two groups were classified together since they possess the same number of stamens. So, these are all the defects which are found in the artificial system of classification, and also no attempts were made to classify the plants considering the natural characteristic feature or phylogenetic relationship. Natural characteristic feature means analyzing both the morphological character as well as phylogenetical and anatomical character, everything should be analyzed in natural characteristic feature. So, these things and all not taken into account in this classification. So, his system was not good. Now, we will move on to natural system. So, natural system, botanists. So, botanists who came after Linnaeus realized that no single character is more important than the other characteristic features. So, as I already said, the scientists who came after Linnaeus, they found out that only the characters which were taken by Linnaeus was not adequate. So, after that many scientists came and they classified plants according to their knowledge, own knowledge. One such system is natural system of classification. An approach to a natural system of classification is sprouted in France. What do you mean by sprouted? Sprouted means germinated, arised. In France it was arised. The first scheme of classification based on overall similarities was presented by Anthony Laurent de Jessie in 1789. The first scheme of classification, it was sprouted in France, that is in 1789 itself. It was presented by Anthony Laurent de Jessie in 1789. So, after that two scientists came, George Bentham and Joseph Dalton Hooker, this is shortly called as J.D. Hooker. These two scientists, they together proposed a system of classification which is called as natural system of classification. A widely followed natural system of classification was considered the best. Still now we follow the Bentham and Hooker system of classification in many of the herbarias. The famous the botanical garden, the largest botanical garden which is present, the Royal Botanical Gardens which is present in Kew, London, also follows the Bentham and Hooker system of classification only. It was proposed by two English botanists, George Bentham and Joseph Dalton Hooker. Bentham belongs to 1800 and 1884 period, and Joseph Dalton Hooker belongs to 1817 to 1911 period. So, these two together they published this classification in 3 volumes work as Genera Plantarum, that was in the period 1862 to 1883. They described about 202 families and 7,569 genera and 97,205 species in the Genera Plantarum. In this system, the seeded plants were classified into 3 major classes: Dicotyledone, Gymnospermae and Monocotyledone. So, as the name indicates, dicots and monocots, we are very much familiar with these two words. Even we have studied in the second lesson about the gymnosperms also. Now, almost you will be familiar with all the characteristic features of the dicot plants, gymnosperm plants and monocot plants. So, dicot plants, what are the characteristic features of the dicot plants? We will see. So, first class is called as Dicotyledone. Well, the characteristic feature of Dicotyledone plants are they contain 2 cotyledons in their seed. Leaves will be with reticulate venation. Taproot system will be present, and tetramerous or pentamerous flowers will come under this class. So, what do you mean by tetramerous or pentamerous flowers? That means the floral parts will be 4 or its multiples or 5 or its multiples. So, all these terminologies you are familiar with in the previous lessons. So, you should be able to describe everything, you should be able to know the meanings and describe the words. Then it includes, again this class 1 dicotyledone includes 3 subclasses, namely polypetalae, gamopetalae and monoclamidae. So, all these terminologies also you learnt in the previous classes, previous lessons. Subclass 1 polypetalae, it includes free petals and diclamatus flowers. So, what do you mean by diclamatus flowers? The flowers which possess distinct calyx and corolla, that means 2 non-essential parts will be present distinctly. It is said to be diclamatus flower. These plants come under the class called as polypetalae, that means plants with the free petals, and the diclamatus flowers come under this polypetalae. Again this polypetalae is divided into 3 series, namely thalamiflorae, disciflorae and calciflorae, based on the position, based on the shape of the thalamus. We will see. Series 1, thalamiflorae, plants having flowers with a dome shaped or conical shaped thalamus. The thalamus will be conical shaped or somewhat globose, that is dome shaped, and superior ovary. So, what do I mean by superior ovary? Superior ovary means the ovary will be located above all the other floral parts. That means calyx, corolla, androecium will be present below the ovary. Such a ovary is said to be superior ovary. The plants with all these characteristic features will come under this Thalamiflorae group, Thalamiflorae series. It includes about 6 orders and 34 families. Then series Disciflorae. The flowers having prominent disc-shaped thalamus with the superior ovary come under this series. Here the thalamus will be disc-shaped, so they come under the series called as Disciflorae, and here also superior ovary is present. It includes about 4 orders and 23 families. And the next series called as Calciflorae. It includes plants having flowers with a cup-shaped thalamus with the inferior ovary or sometimes half inferior ovary. So, what I mean by inferior ovary? Ovary will be located below all the other floral parts, that is below calyx, corolla, androecium. Ovary will be located. Such a ovary is said to be inferior ovary, and sometimes half, that is in the middle position of the ovary, other floral parts will be located. Such a ovary is said to be half inferior ovary. This Calciflorae includes 5 orders and 27 families. Again coming to subclass 2 Gamopetalae, petals with united petals. So, still now we were studying about what Polypetalae and the series included under Polypetalae. Now coming to Gamopetalae, plants with united petals. Petals are all united here, which are either partially or completely fused to one another. Petals will be either partially or completely fused with one another. And diclamidas. So, diclamidas we know that calyx and corolla are present separately, distinctly present. They are all placed under Gamopetalae. Again it is further divided into 3 series, that is inferae, heteromerae and bicarpellatae. So, what is inferae? The name itself indicates the flowers are all epigynous. That means epigynous means inferior ovary. The flowers are all epigynous with inferior ovary. It includes 3 orders and 9 families. Next, moving on to series heteromerae, the flowers are all hypogynous. Hypogynous means superior ovary. Next to hypogynous itself, they have given that hypogynous superior ovary with more than 2 carpels. Carpels will be 2 there. That is more than 2 carpels will be there. It includes about 3 orders and 2 families. Next, moving on to bicarpellatae, the flowers are all hypogynous, that means a superior ovary, but with only 2 carpels. As the name indicates, bicarpellatae, the carpels will be only 2 in number. It includes the group, the series bicarpellatae includes 4 orders and 24 family. Then moving on to the subclass 3 Monoclamidae, the plants are all with incomplete flowers, that is the Monoclamidae is just opposite to Diclamidae. We saw now what is diclamidas flowers. Diclamidas flowers means which possess a distinct calyx and corolla is said to be diclamidas flowers. Monoclamida means here only one, that is undifferentiated calyx and corolla, which is called as perianth, is present here. Sometimes calyx may be absent, sometimes corolla may also be absent. So, these flowers are said to be incomplete flowers, either apetalous, that may be without petals, or with undifferentiated calyx or corolla are present in Monoclamidae. The sepals and petals are not distinguished and they are called as perianth here. Subclass Monoclamidae, sometimes both the whorls are absent, that means calyx and corolla both are absent. Monoclamidae includes 8 series and 36 families. Coming to the gymnosperms, plants that contain naked seeds come under this class. That is, in the previous lesson, that is in the second lesson itself, we studied that gymnosperm plants are all non-flowering plants. These plants will possess the seeds which are naked, that is they are not hidden inside the fruit. So, these are all called as naked seeded plants. It includes 3 families called as Neetaceae, Coniferae and Cycadaceae. Then coming to Monocotyledonae, plants with only one cotyledon in the seed, that is the characteristic features will be just opposite to the dicotyledonous plants. There it was leaves with the reticulate venation, here the leaves are all with the parallel venation. There it was taproot system, here it is fibrous root system. There the flowers are all tetramerous or pentamerous, here the flowers are trimerous. Ultimately, the monocotyledonae has 7 series and 34 families. We saw that divisions, the classifications of Bentham and Hooker system of classification. Now, we will move on to the merits. Why it is still followed now? We will see the merits. The Bentham and Hooker system of classification is still supposed to be the best system of classification. Why? Because it is very easy to follow and the classification was very accurate. It was most stable and reliable. It was analyzed with the actual specimens. It has been widely practiced in colonial countries, northeastern countries, everything, all the countries follow this Bentham and Hooker system of classification, and a herbaria of those countries were organized based on this system, and it is still used as a key for the identification of plants in some herbaria of the world due to the following reasons. What are the reasons? So, as I said already, description of the plants is quite accurate and reliable, because it is mainly based on the personal studies from the actual specimens and not mere comparisons of known facts. That means the plants, both Bentham and Hookers, they themselves studied the characteristic feature of all the plants with the actual specimens. They did not say anything as they heard from somebody else. They themselves did everything, all the experiments, all the analyzing things, and they proposed the characteristic feature of all the plants, and they classified the plants according to the similarities and dissimilarities between the plants. It is quite accurate and reliable. And then, as it is easy to follow, it is used as a key for the identification plants in several herbaria of the world. The herbaria means, we know in the previous session we studied the institutions which store herbarium is known as herbaria. So, in most of the herbaria only this system of classification is followed still now because of its easiness. So, though it is a natural system, the system was not intended to be phylogenetic. So, even actually it is a natural system which took the characteristic features of both morphological character, anatomical character, and even the phylogenetic characters are also considered there, but it was not intended to be phylogenetic. Its aim was not to be phylogenetic alone, but it has analyzed all the other characteristic features also. That is all, my dear students. So, today we studied about the classification, what is classification, what is the need for classification, and what are the types of classification. We studied about artificial system of classification as well as natural system of classification. Study everything, and we will see the rest in next class.